So we were just talking about formation values for these complex ions and that they're really large. They like to be made. And in comparison to KSP, which are molar solubilities, they're not very soluble, or the things that are made in these complexes, like silver with chloride, for example, is not very soluble. So when we combine them, we actually are going to look at both the solubility of the things in the compound and the formation. So when I put, for example, silver chloride, which is pretty insoluble, into solution, if there's ammonia in there, it's going to make this fun complex. Okay, but this is also not very soluble. So you have to take both of those into account. So we're going to start talking really about solubility. So anytime you have problems involving solubility, what you are going to do is combine the K values of these reactions. So if you want to add two reactions together, if you remember back to talking about K, I want to add these, and then that means I multiply the Ks. I remember K is like a step up. From whatever you do to the equation, you do one step up. So if I add these equations together, I can multiply their K values to get a new K value. Now, why would I do that? Well, if I have both of these things going on in solution, I want to take both of them into account. Okay, so silver ions combine with ammonia to make this complex, and this is the K formation for that, very large as per usual. However, silver chloride, which when I put it in solution, is not very soluble. This KSP, molar solubility product constant, is 1.8 times 10 to the negative 10. So if I want to add these equations together, I need to cancel out anything that is on the left side and also on the right side. So a reactant and a product. In this case, the silver ion is the only thing that is that. And then I combine the equation. So I've got AgCl solid and two ammonias make this Ag ammonia complex and a chloride ion. So when I do that, that means I multiply the K. So the K value for this equation is 0.00306. Okay, so when we have KSP and KF, what you can do is add the reactions, multiply the K values, and then you can do an ice table with them to figure out a molar solubility. Okay, so I have, what is the molar solubility? Remember, that would mean I want X, I want to solve for X, and I'm going to do that with this KSP. So I've got nickel sulfide and 0.1 molar sodium cyanide. Okay, so I have the KSP for nickel sulfide is this. So if you don't remember how to write KSP equations, it is the the compound breaking into its ion. So I wrote my KSP equation here, nickel sulfide solid into nickel and sulfide. So remember, the KSP for this is going to be really small, and this is a solid, so it's not included in the K equation. And the K formation for nickel cyanide is this. Okay, so formation equation should be the stuff that makes up that compound. So I've got nickel cyanide 4 with a 2- charge. So that meant, if you check your charges, cyanide's -1, so nickel had to have been +2. So I have nickel +2 plus 4 cyanides makes this compound, and that is the formation constant. So now I can add these equations together and I can multiply my K values. So I add these together, the only thing that cancels is the nickel ion, which is going to be the case for almost all these. It's the metal ion. So I now have nickel solid plus 4 cyanides makes the nickel cyanide complex and some sulfide ions. Okay, so if I do an ice table, I can leave this out because it's a solid. I have my new K value over here too. I multiplied these together and I got 3 times 10 to the 12th. So this is still a pretty big K value. So whatever we do, we won't be able to drop an X. Okay, so I have this new constant equals, I made my ice table. The only thing I gave you that I was starting with is this 0.1 molar NaCN. That means I'm starting with 0.1 molar of the CN part. So that's why I put that here. Okay, and that's all. So then I'm going to do -4x plus x plus x, 0.10 minus 4x, x and x. So I'm going to put all these into my K equation. So 3 times 10 to the 12th equals, now it's products. So x times x, which is x squared, over reactants, which is this. Don't forget to take it to the 4th power because of that coefficient of 4. So it equals this to the 4th. Now I'm going to do a little algebra. So you'll notice I square rooted both sides to get rid of this square. So it's x over 0.1 minus 4x squared. And then I went ahead and used the solver in my calculator in order to solve for x. So x is 0.0250 molar. Okay, so I was looking for molar solubility, and remember, molar solubility is x. So that is going to be your answer. Now, if you wanted to do this without dropping the x, you would have to do all the algebra and do a quadratic equation. Okay, so I would try number 6 on your own. It's very similar, and then check your answer. Okay, so for number 6, I did my KSP equation. So I broke zinc sulfide into its things. That's my KSP. I did the formation of my compound, which is zinc and 4 ammonias make this guy. Formation is this. So I added them together, get the K value is 3.19 times 10 to the negative 12. Now this is a small K value, so I will be able to drop my minus X. All right, I filled in what I have, 0.1 molar for this, same thing. This looks very similar. It's exactly the same as the one we had above, equal to this. This time I can drop the minus 4x, which makes my calculations much easier. And I got that X is 1.79 times 10 to the negative 8. I was looking for molar solubility, so I just wanted X, and that is going to be your answer.